Good morning everyone. So today we are going to do a tutorial to create a PSC box. So this tutorial will include the curve library modeling of a PSC box, and then the creation of the tendon, and then the creation of the rebar as well. And then after that, we would like to assemble the unit, assigning the layout of the assembly unit, and then exporting it to the Midas Civil as MCT file, as 1D dimension and also the 2 dimension. Okay, first thing first, we would like to create the curve library. So this curve library will have the curve library setting, user section setting, constraint plane, and then path length entity. Okay, so today's model will be a PSC box structure with a span of 50 meter. And the first thing first is to create the curve library. So you can just click curve and create, and then change the name to PSC box with the length of 50 meter with direction of X, of course, and then apply and close. And after that, we would like to create a user section setting. So in the user section setting, we have to use the DWG on the file that we have downloaded. So this is the section that you want to import. So to do that, you can just click in the command and click on use CIM user section. And as you can see, this is the list of the user section. Of course, the user section is still none, and you can click on new. And in here, you can see that it asks you to enter the name. So just enter the name of the first section, mid section, and then select object, enter. And then as you can see here, it's asks you to give the base point. So this is the base point. And then it asks you again to enter the second user section name. So you can just type end section and then select object, enter, and then click the reference. And then the third one is the diaphragm, enter, and then select object and then click reference. Okay, so after that you can just click escape on your keyboard, and then as you can see, the preview of the midsection, end section, and diaphragm is all here. Okay, and then you can just click export. And as you can see in here, you can just export them as user section PSC box.wg. Okay, and then just click save. Okay, so after that, we would like to move again to the CIM, and you can just click on the base and user section and click DWG file. And then as you can see here in the user section PSC box, you can click open and then untick the 0 because 0 is the background layer. It is not important because the one that we intended to import is just the midsection, end section, and diaphragm. And then just click on apply and close. As you can see in here in the user section, they have 3 sections that can be assigned to our curve library. And after that, we would like to click on the curve library and then click plane, constraint entity plane, and then just click on the method of by point. So the by point means that the point that you click will be the origin of your constraint plane. But in the offset, you will have a different offset in the layout. So it is important to click on the by point, and then you can just click on the first location of 2 meter, and you click on the alignment by distance. So as you can see, if you click on by ratio, it is not correct because you want to have a constraint plane with a measurement of location. So as you can see, as you inputted 2 meter, you have to click on the alignment of by distance, and then the reference points of a start point for 2 meter, and then the rotation angle of similar, and then you can just click apply, and then 5 meter using also the start point, and then 45, but this one is not start point but end point because it will be nearest from the end point, and then 48. And then we go to the constraint path. After constraint plane, you can click on constraint path, and you can just select all of the constraint plane that you have created, and then click apply and close. So after you have created the constraint entity, you can click on expression entity. So this is to assign the user section that you have created. You can just click path length and create, and then you can click on the main constraint path because the constraint path that you have been created is already here, and you can use the constraint path, the main constraint path. And then for the user section concrete, because this imported section is concrete, and you can click on the select of the constraint path, because after you click main constraint path, it is prompting you to select, so you can just select this constraint path, and then you can click on the end section, as you can see here. So after you select the first plane here, you can click on the end section, and then you can see the preview, right? You can just click assign and then click preview. Because this is one constraint path, it means that the area of the section here will be the same alongside the path that you have created. The endpoint of the section is the other constraint path. So if there is no constraint path in the middle here, the endpoint will be in here. So the different constraint path is just to create the differences of user section area. Okay, you can just click assign. And then for the diaphragm, because we want to add the diaphragm inside of the end section here, so you can just click on the main constraint. Because you have chosen the first plane here, so you don't need to click on select again if you assigning the user section in the same plane. You can just skip this part, and then just click on the diaphragm, and as you can see, the diaphragm is automatically filling the plane that previously chosen. So as you can see here, and then just click assign and click preview. So as you can see, the diaphragm is automatically filling the plane here. And now we would like to add more section to the different path, so you can just click on front here, and then you want to fill this path. Okay, so you can just click on select and click on this path and click on taper section. Okay, so the first section, the start section, will be the end section because this is the first section, as you can see. And the way to do it is to assign this first, assign and then preview. And then just for the end section, you can click on the mid section and then click assign and preview. As you can see here, the opening is tapering outwards. As you can see here, the opening is here, and the opening of the second path is this larger opening, and then just click apply, and then just similarly you want to click on front and select the constraint path of this part, and then click on the midsection, assign preview, apply, and then for the next one will be taper section, select, and then taper section, the start point will be the midsection, assign preview, and then end section will be assign preview, apply, and then for the last one will be select only this path, and then end section, assign preview, edit with the diaphragm. Okay, so after this you can just click on export here to export the curve library. Okay, so moving on to the tendon modeling. So to see the tendon inside, of course you have to click on view, and then you can click on this button and click transparency and click concrete member mono and 0.2. Okay, as you can see, the opening is seen to be tapered this way. Okay, and after that you can define the anchorage for the tendon. So it's similar to last classes. You can click on model, you can click on the tendon and anchorage. Okay, and you can click on the anchorage type and etc. here. You can click on the manufacturer of VSL with the anchorage type of plate E612. Okay, and display spiral reinforcement. So the anchorage has been created, but it's not shown yet because the tendon is not been created yet. So in this case, we would like to create the tendon. So just click on tendon and create, and just change the name to tendon group because we only have one tendon group, and click on default constraint path with the selecting of reference member. The reference member will be all of them. Okay, so just click here and then just select all of them, and then for the, as you can see here, there is a wide direction of section. Why is it important? Because we want to the inputted number in the tendon creation is, it is important to know the where is the y direction is headed. So this is important to see the orientation of your modeling. Okay, and you can click on the add tendon group after that. So this is the tendon editor. To use the tendon editor, of course, the first one is to click on the property, okay, and you want to keep this classification, tendon 1 and SS 400 with the tendon type of internal post tension, okay, with a strand diameter of 15.2, with a number of strand of 12, and in this case it's a duct, as you can see here. So this is just the section of the tendon property. Either you want to define the end of the tendon as a round or a flat. In this case, it's a round with a diameter of 0.087 meter. And then after that, you just click on the Create tab. After you click Property, you can click on the Create tab. And then make sure that the tendon creation is longitudinal because we want to move them along the longitudinal side. Okay. And in this case, we want to start and end point of anchorage using anchorage in the start and end point. This is the anchorage that we have created before. And then just click on the 3D coordinate. And then in this case, we want to open the tendon coordinate in the Excel. In this case, we have a data Excel pointed out in here. As you can see, this is the tendon input from T11R until T18L. You can just copy them and then just paste. Okay, and then just apply and close. As you can see, the tendon is automatically inserted in the section, and as you can see, the anchorage also automatically assigned because you already ticked the use anchorage in the start section and the end point. Okay, and to edit the tendon, the easy way is to click on the tendon here, and then in this case it's a tendon group. You can right click and you can click add and modify tendon. So in this case you can see the editor, but if you want to edit, so for example, as you can see here, if you hover your cursor in this list of tendon, you can see, for example, this one T11L. You can click here, and then as you can see, there is a different button here. You can edit them in this case. But if you want to edit them comprehensively, so edit with the tendon editor, you can right click and click modify. It will gives you the similar tendon editor, but in this case, this is the actual coordinate table for that particular tendon, so the T11L. You can also change the other tendon by clicking this drop down menu. Okay. The way to export them is similar. You can just click export and then click on curve library PSC box tendon. Okay, now we are moving on to the assembly unit. So after you have got the tendon modeling here, to assign the assign the assembly unit. So this assigning of assembly unit will be involving the importing of the curve library, creation of the constraint plane, and then assigning the both curve library and point library. So this point library is for the abutment, the abutment of this part of the start point and also end point if you only want to have this span. Okay, so to create the assembly unit, it means that you will have a lot of curve library and a lot of point library. Okay, so the way to do it is just to import the library that you needed. As you can see, this is the creation of the curve library mode. So you can just apply and close. As you can see here, you have only one curve library, so only the PSC box. So you want to have more, so you can just click on curve and click import. And then in this case, you want to import all of them because you already have the PSC box, so you don't need to import this. As you can see, you have imported the curve library, all of them. And you want to also import the point library. So this point library will be for the apartment, as you can see. So the important thing is that in the work tree, if the import is successfully created, you can see clearly that the point library is available and the curve library is available in this case. Okay, so you want to create an assembly. After that, just click on create an assembly and you want to change the name to AU-PSC box. Apply and close. And after that, you can see in this case, you may remember that in our previous curve library creation, we only click on the constraint entity in plane and path, and then after that we create the path linked in the expression entity. In this case, because this is a combination of many curve library, you want to click on space for the constraint entity. Okay, and in this case, we can just keep the connected and then click on default space. Okay, with the space name of similar AU-PSC box with a unit length of 51 meter. Okay, and then just apply and close. And then similar to our previous curve library creation, you can just click on constraint entity and plane here and click on the as you can see in the create tab, you can click the method of by point with the location of the first one is the 0.5 meter, alignment of pi distance, don't forget, and then origin of start point for the 0.5 meter, and then 50.5 in the endpoint for the last one. And then for the constraint main path, you can click on path and main path here. And in this case, we want to only use the inner path, inner plane here. You can just click both of them and then change the offset of minus 2.9625 with the z direction of 0. Okay, and then just click apply for the first one, and for the second one is apply using the same constraint plane, apply and close. Now this is important because this is the constraint path for the paving, and the point library that we have imported contains of the paving and the left barrier and the right barrier. So in this case, we want to add another constraint path, but this constraint path will be for the left barrier and the right barrier. So we have to select the constraint plane again. In this case is this one, and then check the offset y of 5.62, apply, and then minus 562 for the next one, apply. So this is for the left barrier and the right barrier, and for the last one will be for the main barrier. So this main barrier is not particularly in the y direction, but this will be in the z direction. So this z direction is for the bottom part of the bridge. So you can just go ahead and click on the constraint plane, okay, and then just click 0 in the y direction and minus 0.08 meter for the z direction. As you can see, the offset in the Z direction is available in this case here. Okay, and then just click apply and close. After you have created the constraint entity in the space, path, plane, and path, okay, you can just assign the curve library. As you can see, this is a assign library. You can click on either point or curve, but in this case we want to assign the curve library first. Okay, we can click on the curve, and we want to apply the PSC box. Okay, this case, this one. So you have to click on the PSC box, and then click on the main constraint path, because all of the constraint path is already selected in the main constraint path. So you have to be careful. If you select this, you have to select the generated in the 0.08 meter here, because we want to have the PSC box below the point library that we have created, and the point library of the imported part and the curve library of the imported part will be on top of the PSC box that you have created. As you can see here in the preview, you can click apply. Okay. And then for the second curve library assignment, you can click on the left barrier first, and similarly you can just after you click the left barrier, you can just choose the selection of this one, then apply. And then for the right barrier, similarly you can just select this one and apply. And for the medium is in the middle, so just click on the medium barrier and select this middle part. And for the pavement, it's also similar to paving. You can just click on the paving and click the select. You can click on the paving and select this path and select another one. Okay. If you cannot distinguish the differences between the paving and the concrete, maybe you want to change the transparency again. That's okay. You can change to 0.5 maybe. In this case, you may be able to differentiate between the paving and the PSC here. Okay, and the next part is so after you have used the constraint entity of space, plane, path, and then after that the last point is the constraint entity of point. You can click on the point here, and then of course the method is point, and but this one we click on the default constraint path with the location of 0. Okay, location of 0 first, and then the second one is the 51. Okay. So in this case you have two constraint point. Okay, so the purpose of the constraint point here is to apply the point library that you want to assign. Okay, so in this case you can just click on assign point library and click on apartment 1. So apartment 1 will be in this part. So you can just select the constraint point. As you can see, constraint point, this one, and then just click apply. And then for the next one will be the apartment 2. Okay, and apply. As you can see, this is the assembly unit, and you can just click on export, and you may want to change the name to maybe export AU PSC box. Okay, so this is the exported assembly unit modeling. In this case, you may want to close the assembly unit first. And in this case, if you want to add maybe a rebar, in this case, you can just click on model and you can click on rebar and draw. Okay, then you can click on target member, select plane, select direction. As you can see, this is the section that can be shown. Okay, to create the rebar for the PSC, you will first have to create the transverse rebars in the top slab. So it will be in this area, in this slab area. So you can just click on the transverse rebars and click on property, untick the auto name T1 ST400 with a rebar code of Korean code, with a D of D22, with the bending radius of 66.6. Okay, with a cover thickness of 60 millimeter, the distance between the outside layout to the rebar, and the cover align center of 100 millimeter, with the offset of 60 millimeter for both sides, and it has no hook. And to draw them, you can just click on the straight bar in the draw here and just select the top hand side. Okay, and for the transverse rebar in the website, you can just change the name to W1. Okay. Similar to last one, bending radius of 66.6, but with the cover thickness of different. So the 60,3 at 50 meter, comma, and 60. Okay, with the part length of 0. So this part length of 0 means that the offset that you want to create is 0 millimeter from your rebar length at the end. So it means that there will be no offset on the either start length or the end length of the rebar. And you want to give a hook with a different start and end hook. The first hook will be 135 degree plus, and the end hook will be minus 135 degree. Okay, and to create this, you want to click on the draw tab, click on transverse rebars and select member edge. So this member edge will be connecting the top bar to the web of the PSC box. So this will be starting from this part. Okay, so starting from this part to this part, this part, this part, it will extending until this side. Okay, so as you can see, you can just click on this. Okay, and then this, and then this part, this part, and then moving towards this is this part. Okay, yeah, don't forget to create the offset of 0. And for the member edge, we want to create this one more time. Okay, let's try this one more time. So you just have to create this in between, and then this, this, this. Okay, this one, this one, this one, and the last one will be this one. As you can see, the important part is that the hook is interacting with the top bar. Okay, so the next one is to create another transverse rebar. Just click on the property. But in this case, we want to add another rebar in the right hand side. As you know, this rebar is similar to the left hand side, but you have to create them in the right hand side. So just similar to the last one, just click on this part and this part, this case, and this case. As you can see, they have a similar mirror. Okay, but you may want to, as you can see, this is W1 and W1, so you may want to change the name of the W1 to W2 maybe. After that, we want to create a rebar for the web. So this web rebar will be in this part, so covering the bottom slab, connecting to the inner website in here. Okay, so the property will be the T to L, because this one is for the left side. We will create them for the right hand side later. The bending radius of 57.3 with the cover thickness of 60, 40, and then 50. Okay, for the part length, it will be 300 millimeter for the end length, because we want to extend this further in the end side. Okay, there will be no hook. Okay, so it's time to draw. So again, it's a similar, click on draw and click on select member edge for the transverse rebar. So it will start from the vertical side of the slab. Okay, first one, and then this is the second one, and then the third one will be this side. Okay, as you can see here in the property, the reason why I click on the part length of 300 millimeter is to trim the last 300 millimeter from this part, because if you click on 0, for example here, you can see that the shape of the rebar is only until this part. Okay, because as you well know, I already clicked this part and I already clicked this part, right? But as you can see, there is no rebar in here. So the first side that I have clicked will have no rebar at all, but it's just a mere this starting point of the rebar. So I click this one first, and then this one second, and this one third. So the start point and the end point will have no rebar at all. But if you click on the part length, maybe in the end side is 300 millimeter and the start point is 300 millimeter as well, you can see that the 300 millimeter is extending in the end side, and also it's extending in the right side. Okay, so but in this case we just want to extend the rebar further in the end side. Okay. Again, this one is similar for the right hand side. Okay, this one is T2R. Okay, for the end length as well. And click select member edge. So the first one, the second one, and then the third one. Okay, so now it's for the slab edge. We want to click draw again. Click on transfer C bars and click property. Click on J1 with the D13, 38.1. This one is for the edge, this part, with the cover thickness of 2 at 60 and then 40. Okay, but for the right side it will be the opposite, 40 and then 2 at 60. Okay, and for the part length it will be 500 millimeter and 500 millimeter as well. Offset is 0, no hook. So it's time to draw. We would like to draw the member, but in this case we would like to use the select line. Why do you want to use the select line? Is because the area that we want to cover is only this part, so we don't need to have a lot of maneuver like the one like this part and this part, because in this part, in this rebar, we will have to cross this different shape, and also this part we also have to cross different shape and different space in here. But in this case it's a closed circuit, so it's a closed path, so we just need to click on select line. Okay, just select this line, and this line. Select this line, okay, this line and this line. Okay, for the next one is the J2 with the cover thickness of 40 and then 2 at 60. Select line as well. Oh, sorry, select line. First, second, third. Okay, so as you can see, it's already connected with another rebar. Now we want to create the bottom of the top slab. Okay, again this one is also transfer C bar with the property of T3, D19, and 57.3 with a cover thickness of only 40 with no part length at all, and the offset is minus 1135 with no hook. Okay, so you want to click on the strike bar and just similar, click select and click this side. So as you know, if I don't click on this offset, the rebar will be uh, increasing until the part. Okay, and the next one will be in the web outer. So in this case, this one, the web outer. Um, So it will be also transverse rebars with H2 or maybe H1, T19 with a 57.3, cover thickness of 40 and then 50 with the cover thickness of 100 millimeter with a part length of 300 millimeter with offset of minus 600. Okay. This will be select member edge because it will be across this space. Okay, so in this case it's a H1, so this will be from this part and then this part. Okay, and then for the next one, the left hand side, is this and then this. Okay. And another one, V1, D16, 47.7, cover thickness of 50, 40 and 50 with a part length of 200 millimeter. The offset of 0. Okay, so this one is also member edge. So this will be including the from this part to this part to this part. So that means that it's a member edge. So the first one is this one, and then this one, and then this one. Okay, select member edge. Okay, so this part, and then moving on to this part, and then this part. So it will cover the outer part of the web, the inside part of the opening part, and then the outer part of the web as well. As you can see, the offset part length of the start and end looks like this. Okay. Remember, because this is a member edge, it means that the first part and the end part is not included unless you click on the part length here. So if I zero this one and zero this one, it will looks like only straight line. Okay. And then the last one is the bottom slab in here. So just similar. This one is P2 D16 47.7 with the cover thickness of only 50 because the thickness is only this part, right? Because in this case, why is it a 50 40 50? Because the 50 is this one, 40 is this one, and 50 is this cover thickness. So yeah, and it's similar. No hook. Okay, and in this case you can use straight bar, but because we have member, because we have part length, so it is advisable if you click select member edge. Okay, select member edge, and then select from this part to this part to wait to this part. Okay, so you can see here, this is the rebar that has been created, and the reason why it's not straight bar, if you click on select bar, if you click on straight bar, the offset, the part length that you have created here, the 200 millimeter, in this case, this one, yeah, this one, will be straight. So the reason why we choose the select member edge is to follow the shape of the rebar according to the member shape. So yeah, so after that you can just finish, and you have your rebar. And then after that we would like to array our rebar. Yeah, but this case we have to draw another rebar. Okay, wait. Okay, we have already created the transverse rebars. Now we have to create the longitudinal rebar. So the first one will be TL1. Okay, with the D13. Okay, no hook, offset 0, with the arrangement of adjustable spacing of 250 millimeter. Okay. So in the longitudinal rebar, you can just select transverse rebars and select them. Select the first transverse rebars and then reverse direction. And now we want to create the transverse rebars for the bottom part. In this case, you want to click on the user define because you want to have different spacing. Okay, and the name is TL2L. So this is for the left side. Okay. Don't forget to click on orthogonal spacing. Okay, this orthogonal spacing. So this one is specified that you want to have the spacing in the x direction instead of the y direction. Okay, so in this case you want to draw, select transverse member and select transverse rebars. Okay, apply, and for the right hand side it will be similar. You just select and draw reverse direction. Okay. Now it's a longitudinal rebar for the bottom part, and this one is the TL3, T13, no offset with the pattern spacing, 2 at 250, 34 at 125, 2 at 250. So the difference between the pattern spacing and the user defined is pattern spacing is you have start point and end point similar to each other. That's why it's a pattern. But if it's a user defined, you just make the pattern as wild as you want. Okay. In this case, you want to select transverse rebars in draw and select on the top, bottom slab. And reverse direction. Okay. And now for the haunch. So this part. Um, you want to change it to user defined with only 8 at 250. The HL1 for the left, T13 with a start spacing of 310. Okay. So for the haunch will be this part. Okay, so just click here and click, and for the right hand side, sorry. For the right hand side, you can just select this word, reverse direction. So you don't need to change this one because this is the start spacing. So no matter where you start, you will start from the part. So you don't have to click on start spacing or end spacing. This one will be similar on both end. Okay. And now, because as you can see, this rebar is looks to be very complicated. You can just hide some of them, as you can see here. This is the bottom rebar. You can just hide them to to make life easier for you to assign another rebar. Okay. So in this case, we have to click launch the rebar, and then WL1 P13 with a start spacing of 500 millimeter, and user define of 10 at 200 millimeter. And now in this case, it's a y-axis, the original spacing, because we want to add the spacing in the y direction instead of the x direction this one has. Okay. And in this case, in this drawing, we want to, instead of the select transverse rebars, we want to select the 2 points. Why it's 2 points? Because we only want to add a rebar in certain places. So, for example, if you click on select transverse rebars and you click on this one, you will have the longitudinal rebar in all of the rebar itself. But if you click on select 2 point, you will only select those 2 point. Okay, as you can see, the rebar here only chosen in that point. So it is useful if you only want to create a rebar in some particular area. Okay. So this is also similar. You can change to WL4 for the right side. Okay. Just click from here to here. Okay. Now WL2 for the left side again. So this part will be the point from similar part, but it's in the right hand side of the left hand side. So you can see here, it's just from this part to this part for WL2, and for WL3 is this part to this part. Okay. Now we want to create in the x-axis again. So you must remember that the original spacing will be x direction, and this one will be adjustable spacing, because as you can see, the spacing is very small. So it means that if you create the spacing of 250 millimeter and you create on the pattern spacing or user defined spacing of or uniform max spacing, you will have only maybe 1 or 2 rebar that is not correct in terms of the spacing. So the adjustable spacing is important if you have small area to work with. Okay. Yeah. So the name will be BL1 with no offset at all. Okay. So this one is not 2 point. Now it's select transverse rebars again, and so you have already started this one, but now it's the bottom slab, so you want to show all of them, and then select this one. Okay. And now for the PL2, it's similar. We want to add for the bottom part. Just click this one, reverse direction. Okay. So this is a completed part of the rebar. Okay. So as you can see, if you want to array them, just click on the rebar and click array. And as you can see, the rebar is already selected. You can just select them. Okay, 24 selected. And then you click on the select array main target member. So the array main target member will be all of them. So just drag all of them. And for the select plane, the end plane will be the last plane, of course. This one. And you want to change the property first. The property will be the spacing. The spacing will be pattern spacing of 200 millimeter or 0.2. You can just click apply. Here we go. Yeah. So as you can see, the rebar that is starting from this part, okay, starting from this part, as you can see, this is the longitudinal rebar and this is the transverse rebar. It's already arrayed in every rebar here, alongside with the tendon. Okay, and this is important because the correctness of your assigning part is important, because you don't want to have the tendon intersecting with the rebar. That means if you have maybe different appliances application in your coordinate of your tendon or the coordinate of your rebar, it will be difficult to solve the array. So you have to be careful on assigning your rebar array. Okay, so after we have created the curve library with all of its tendon, with all of its rebar, you can just click apply and close. Okay. Okay. And as you can see, so as you can see here, in the point library, there are abutment 1, abutment 2, and the curve library have PSC box, left barrier, middle barrier, paving, and right barrier. But we need more point library. We need a T-shaped pier. So to do that, we just click on library and then click import, and then click T pier to import. Okay, and then we can just click assembly and click create to create a 3-span PSC box. Okay, so the space name will be 3-span PSC box with a unit length of 170 meter. Okay, okay. After that, just similar, you can just click on constraint plane and just first click on pi point, alignment by ratio 0.2. Okay, and then 54.8, and then 55.2, 114.8, 115.2, and then 169.8. Okay, so this is for the constraint plane, and now we are going to create the constraint path. This is similar. Just click on main path, and for the y, 2.9625 for the y direction. Okay, but in this case, we want to create a paving, right? But the reason why we have a lot of plane in here is because we want to divide them um, by pier and etc. That's why we want to hide this selected. Hide selected. Okay, wait. Okay. And then we want to click on main path and select constraint plane, and then the distance path will be 2.9625, and select path again, and minus. Okay, so this will be a paving, and the other one will be for the left barrier, mid barrier, and right barrier. This will be, first one will be minus 5.62, and then plus 5.62 okay, so the plus 562 and minus 562, don't forget we have to include the y offset of minus 0.08, because the bridge will be under the z direction of minus 0.08 for all of the offset, either the left side or the right side or the middle part. Okay, so this one is the case, and for the next one will be minus, and the last one will be 0. Okay. Okay. So you can just name the constraint path. So for this case, it's a R barrier, and this one is L barrier, this one is M barrier. Okay, and so you can just show all, and then the last one will be constraint path for all with z of minus 0.08. And then apply and close. And similar to constraint point, and in this case the constraint point will have a 4 point. First one is the 0, and then 55, this one, and then 155, and the last one is 170. And just assigning the point library is simple. Just click on the first point library and follow vertical path axis, and then just click apply. And then for apartment 2, it will be the endpoint, and just click apply. And then for pier, you can just select them, apply, and then the other one, apply and close. And now you want to assign the curve library. You want to assign the PSC box. It's similar. Just click on the main constraint path, and select the path. So remember, the path should be the bottom part. So yeah, click on main cursor path and click on the three path that is in each of span, and then just click apply. Okay. And now for the left barrier. Okay. As you can see here, because there is too many choices, as you can see, there's too many rebar, and you can barely see the main constraint path. Okay, you can just freeze them, as you can see, and just unfreeze some of them. So it means that the important part of your barrier, the main path is preserved. Okay. Moving on, we want to click on the sine curve library and click on left barrier. Click on main constraint path and select the left library. Enter. Okay. And for the middle right barrier, and for the right barrier. For the paving, left side paving and right side paving. Okay. If you want to see it clearly, you can just change the transparency, maybe to 0.9, or maybe how about no? Okay. You can see that the assembly unit is created here, and the next way you have to create the layout. So after you apply, okay, you can see that the assembly unit, this is the first assembly unit that we created before we assign the rebar, and this is the assigning of rebar and assigning of another span and another T shape. Okay, and we want to create the layout. So in this case, we want to add maybe three with a straight, arc, and straight, with the first length of 55, with the second length of 60, third one is 55, radius of 150 millimeter, 150 meter. Okay. And for the horizontal alignment, okay, you can see in the vertical alignment, we want station 0 and station 170 with the elevation of 3.4 meter for the last part. So it will be upwards. Okay, and in terms of the segment, we want to create another segment with the start and end, with the skew of 0, with the label of on, and super elevation we keep it simple and just apply. Okay, and then to assign the layout, to assign the assembly to the layout, you can just click on assembly and click assign, and click on whole layout, select layout, and the alignment will be tangential because we want to make sure that the assembly unit is aligned with each turn of the layout. Okay. So just after you add them, you can just click on apply and close. Okay. So after you have created the assembly, you can just first create the rigid link. Okay, and to better assigning the rigid link, you can just hide the rebar and tendon. So after you hide the rebar and tendon, you can just click view and transparency and click on mono, maybe 0.2, so that, as you can see, the hidden tendon and hidden rebar here can make it easy to isolate this one. So in the front, you can isolate this part. Okay. So in here, you can create the rigid link by clicking on the model and clicking on the boundary and rigid. So this one will be vertex to 1D member. So the vertex will be this one. Sorry. The vertex will be only this point, okay, 2 point, and then 1D member will be this one. Apply and close. Okay. So this is similar to the other one. So if you can see here, maybe maybe you want to show only maybe this part and this part and this part. Okay, and you want to delete this one and this one and this one, hide selected, and do a similar thing. Boundary rigid vertex to 1D member. The vertex will be similar, so 1, 2 member, 1, 2 member. Okay. Okay, similar to this one. 1, 2 member, 1, 2 member. Don't forget that the master point should be 1D member because the master point is in the top side. This one is similar, 1D member. Okay. The last one, this one should be okay. Oh wait. Yeah. And then show all. And the rigid link is done. So after that, we want to create the vertex link. Elastic link. So just okay. For the elastic link, it will be for the pier, but in this case, we want to create another rigid link for the pier. Okay, but first thing first, we have to isolate the T pier first. Okay, this one and this one. We want to click show only, and then similar rigid link, vertex to 1D member, and the master member will be 1D member. That the vertex will be the vertex in the this side. Sorry. This side and this side, and the 1D member will be this part. And sorry. So the rigid link, is a vertex to 1D member, right? But the 1D member will be this part because as you can see, the vertex is in this part, in this 1D member, Okay, with the master point of 1D member, with the vertex of the point of this one and this one. And similar to the other, vertex, vertex, 1D member, master point, 1D member. Okay. And for this one is a vertex and 1D member. Again, this one is up to you. Either you want to click on the left hand side for the 1D member or the right hand side is okay. And this one is vertex vertex 1D member, vertex 1D member. Okay. And now for the elastic link, we will be using this one again. Okay. This one too. Okay. So boundary and elastic link. Okay. So with the start point of each, this one, the end point will be this one. Okay. With the stiffness of, we let link type of general with the stiffness of you can change it to kilonewton, 1000 1122000 with a dy of 4018. Okay, apply, and then you click on the other vertex, and the end vertex. Okay. And similar to the other, just click on start vertex and end vertex, start vertex, end vertex. There you go. You can have a rigid link, and elastic link. This is for one pier, of course. Yeah. Okay, so This one is already created too. Okay. Okay, after we have created all of them, you can just click show all and click on application and click analysis case. This analysis case is important if you want to apply the model to the Midas civil. Okay, so you just click on analysis case, click define, and you click on analysis case 1. Okay, and then for 1D element you can just select, and then for 2D element, this is the 2D element, and then for boundary condition is already selected as well. And you can change the mesh size of the 2D of 1 meter, and mesh size of the 2D is also 1 meter, for example. And then you can also export the self-weight and analysis case 2, for example. Okay, and then after analysis case is already created, you can just click on Midas civil and change to analysis case 2 and run the Midas civil. In this case, it will be Midas civil NX. Okay, as you can see that the model is already created in here with the section and taper section and thickness, as you can see here, and this thickness can be changed. So that's it. Okay, thank you very much. We will be meeting again to discuss the tutorial of PSC beam bridge. Okay, thank you.